The next thing we're going to talk about are ways of measuring, types of variables we have, and then sort of looking at disbursement. And I know you're kind of thinking, why are we doing this? It doesn't seem as important as some of the other stuff about statistics, but it really is. The type of variable that you have is very, very important because that sort of determines what tests you can do. And I know that they sort of make statistics seem like one size fits all, and then you can do any statistical test you want, but really your data and the way it's collected is very limiting to what you can do, and also the numbers. And then within each variable, you need to sort of know some inside information in order to sort of see and understand the outcome of the test. So it's sort of a prerequisite to, if you're in medicine, ordering labs so that you can understand them. It's sort of a prerequisite of understanding a program or an intervention or an evaluation you're doing, maybe even knowing something about your sample population. So it's similar to that. There are different ways. A scale is the way that we actually collection of attributes to measure a specific variable. Okay, so we might have ones, and the ways in research we talk about that is what type of variable it is. So it's a measurement level. One is not better than the other. Some things you can't measure any other way. Some things you can measure one way and turn into another way. But we're going to start with the first thing, which is sort of nominal data. And that's sort of like gender or race, and you assign a value. So if it's gender, you might say 1 for male, 2 for female, 3 for other, 4 for trans. Those kinds of ways of doing that, you're assigning that value. That value doesn't mean that males are number one and that it's more important or a higher value to be something versus another. It's you assigning a value to that nominal. It usually doesn't have an endless supply of categories, but it has sort of a yes, no, 3 or 4 variables. Sometimes our control variables are like that. So we can take even like the level of education and we can say, that can be a continuous variable, which we'll talk about later. But you could also say, do they have a high school education or not? Yes, no, 1, 2. Okay? Those are nominal variables. And you're going to have these kinds of variables a lot of times in what we call socioeconomic status variables and ways we measure those. You can't really turn a lot of those into continuous variables, but you can use nominal variables. And nominal variables are really important when we're sort of learning about our subject sample population that we actually gathered. So it isn't better or worse, it's just a type of variable that we have, and it leads us to certain kinds of tests we can do. So that's sort of reason why we're going over this early in the game. The next one is sort of ordinal. So they have a certain ordinance to each other. So it might be that, there's a determined, high, medium, and low, and you would determine what is high, medium, and low. You would set this value up. Interval or ratio have a determined distance. Continuous variables you might hear spoken about too. And what is that so your age, that can be 1 to 100. Your level of education, you can set that up as a continuous variable. A lot of things that you can assign numbers to. So there's the same equal number between each one. So from 1 to 2 is one number, from 2 to 3 is one number. Degrees, sometimes we can do, if you're doing medicine, you can do blood pressure, but you can also turn those kinds of continuous variables into ordinal variables. So high, medium, and low blood pressure, pre-diabetes, type 1, type 2 diabetes, and you would assign a value to that. So there are specific and a lot of interval variables, which is different than ordinal, because ordinal, you're making the order. You can change back to nominal. You can say someone got a test score, right? So that's a continuous variable. They could go from 0 to 100. But then you can turn that into, did they do a high or medium or low level on that test? And you would just, again, assign in your methods section how you determined which was high, medium, and low, which score they got, and divide it up. Or you could say, did they pass or not pass? Right? So then that would be a nominal. So a lot of continuous variables you can go backwards on, but nominal variables you can't go forward on. Now, there's none better than the other. You just want to have, and often your studies are going to have a mixture of these. And that's sort of just the way it is. So if you're doing a pre and a post test, you could do specifically, did they get one question right or wrong? Then you could say, what was their score on the whole test? Then you could say, were they high, medium, or low? So you can make it into each one of those variables. Nominal would be, yeah, they passed or they didn't. Ordinal would be high, medium, and low. And then a ratio variable or a continuous variable would be their actual test score on a scale of 0 to 100. So again, once you've got the data, we can cut it, parcel it all kinds of different ways. It's best if you've got a continuous variable because you can sort of go backwards, like I just said. It's a little bit harder with nominal. So, but sometimes that's the way it is, and you have to sort of take the data as it is. But a lot of the studies that you're going to do, you're going to look at, or data that you would actually use in real life, is going to have a mixture of those variables. So it's not an either-or situation. Having said that, though, one of the things that you sort of first do is you sort of visually look at your data before you do any sort of statistics. Because what you're trying to look for is there sort of an initial story? Is there one variable that stands out the most? So did 80% of the class get a 95? And that would be your mode. So that's the most, the value that repeats the most, okay? But then if you wanted to do the mean, you would add up all the test scores, divide it by the number of people taking the test score, and see what the mean is. Now, the mode, not so much. It's fine because it's whatever's happening the most, but the mean is going to be really, really impacted by if you have a lot of people who score really high or a lot of people who score really low. And that's called outliers. And that can sort of throw off our data, even if it's continuous data, because it might say we don't have a variable that's significant with another independent variable, and it might be because we have people who are outliers. And if you remember that statistical regression, which we sort of talked about, and some studies just have people who are outliers. Or they'll have a lot of people who don't have variance, right? And that variance is that bell curve that we expect. So there'd be a lot of people in the middle, and then a few people over on the other end. That doesn't always happen. It's what statistics is based on, but that doesn't always happen. And we sort of look at the data, do a quick sweep of it, and we look at the mean, the median, which is sort of the point in the middle, right? So between 100 and 25, whatever's in the middle of that. But we also look at the math mean, which is we add them all up and then divide by the number of cases there are. And there again, outliers can really impact it. Same with the mean. If you've got some people way up here at like 100 and a few people down here at 0, you're going to have a lot more. Your mean is going to be a much higher point. Again, outliers really impact that. And we need to know about outliers because when we do other tests in statistics, that can skew our results. It can make it seem like there's no relationship, and there is, and we would have to redo our stats. So the first thing we do is we sort of plot it, and you can look on SPSS, and you will plot your data and see sort of where it's at, what are your frequencies within each variable. You also want to look for the mean mode, especially with continuous variables, so that you can see if you have outliers, to see if you have some patterns that are showing up right away. And that's a really good sort of first sifting of what's going on, and the first sort of layer of a story which might be happening. And you always want to keep track of this information. You don't sort of do it right away. You want to keep track of this information because later when you do the tests, they can help explain it. In the same way that history and physical can help explain which tests you order, it also can help you figure out how to interpret those tests. Because again, it's not one test fits all. Sometimes you get back weird results or you have certain kinds of data and then you have to do certain kinds of tests. So again, the type of variable you have will determine what kind of tests you can do and what is contained within that variable. Is there natural variation? So that you have a nice standard D where you have a lot of the cases are in the middle and then there's a few cases at the end, that nice curve. You may not have that, and that can help tell a story. So we always sort of do this first sifting of the data to look and see what it's telling us.